Section 2.6 Other types of equations. Solving equations involving rational exponents. Rational exponents are exponents that are fractions, where the numerator is a power and the denominator is a root. For example, 16 to the 1/2 is another way of writing the square root of 16. 8 to the 1/3 is another way of writing the cube root of 8. The ability to work with rational exponents is a useful skill, as it is highly applicable in calculus. We can solve equations in which a variable is raised to a rational exponent by raising both sides of the equation to the reciprocal of the exponent. The reason we raise the equation to the reciprocal of the exponent is because we want to eliminate the exponent on the variable term, and a number multiplied by its reciprocal equals 1. So for example, 2/3 times 3/2 is 6/6, which is equal to 1. 3 times the reciprocal 1/3 becomes 3/3, which is equal to 1, and so on. Rational exponents. A rational exponent indicates a power in the numerator and a root in the denominator. There are multiple ways of writing an expression, a variable, or a number with a rational exponent. We have a to the m over n is the same thing as, in parentheses, the base is a to the power of 1 over m to the m power. Or we can say that a to the m has a power of 1 over n. And we can rewrite this: the denominator of the fraction is always the index of the radicand sign. The radical sign. And then the numerator is always the exponent of the radicand. We can also say that this is the nth root of a raised to the mth power. So for example 1, we're going to be evaluating a number raised to a rational exponent. Evaluate a to the 2/3. Whether we take the root first or the power first depends on the number. It is easy to find the cube root of. So if we have a to the 2/3, we can then write the base as 8 to the 1/3 to the second power. 8 to the 1/3 is the same thing as saying the cube root of 8 raised to the second power. The cube root of 8 is 2, and when we square that, it gives us a value of 4.